Welcome to Introduction to Logic or Introduction to Symbolic Logic. My name is Dr. Micah Bailey, or you can call me Dr. Bailey, and I'm going to be your instructor for this semester. What we'll be studying is first order logic, or what is also sometimes called FOL, or FOL. And what I want to do in this video, in this introductory video, is to give you a sense about what first order logic is, but I also want to give you a sense about why you might think that it's important. First order logic deep down is a kind of language. And unlike English, it's a symbolic language. English is what we call a natural language. And what a symbolic language does is it encodes certain features of a natural language. And by encoding them and using particular symbols for those features, it highlights, it brings to the forefront of our consciousness those features of language. Specifically, we're interested in the types of structures that statements can take, and then also when those statements are used to prove or be evidence for another statement. We're also interested whether it really does support that other statement, whether a premises or the evidence really does support the conclusion. And by highlighting the structure of these languages, we can better assess whether evidence really is good evidence for a conclusion, whether it really does support a conclusion. So that's what we're up to. Now, for first order logic, that's divided into two parts. There's propositional logic, or what's sometimes called sentential logic, and then there's quantificational logic, or what's also called predicate logic. Although we're going to see with our textbook that it introduces predication when we're still talking about propositional logic, so there's this sort of gray area, but usually predicate logic is associated with quantificational logic. All right, so let's take a look at propositional logic. Here we have some very basic examples of statements that we have. The grass is green, it's not snowing outside. The grass is green and it is snowing outside. If the grass isn't green, then it's snowing outside. So what we might do in propositional logic is represent an atomic sentence, such as the grass is green, as just with one capital letter, such as a G, for instance. But then what we'll also, as we get further along in propositional logic, we'll start introducing more symbols that represent certain logical aspects of language, of statements. So if we look at it's not snowing outside, we need to be able to represent the not, which is saying that the snowing outside statement is false. So we'll use a symbol like that to encode that negation, that not part, and we might use S for snowing outside, or you might use O for snowing outside. When we look at the next sentence, it says the grass is green and it's snowing outside. In this case, we've already used the G for grass is green, and we've used S for it is snowing outside. But what our sentence here is saying is that the grass is green and it is snowing outside. The symbol we use to show that and, or what we call a conjunction, looks like that. Or this last sentence that says, if the grass isn't green, then it's snowing outside. So here, this first part, which we call the antecedent, we're saying if not G, oops, that didn't come out all that well. If not G, then that's supposed to be an arrow, then S. So if it's not the case G, then S. And now our little handlebar symbol and our arrow symbol highlights to us the logical structure that is taking place in the sentence that it's representing, namely the sentence above it, which says if the grass isn't green, then it's snowing outside. Now, if this is seeming like it's going really fast and that it's too complex, I don't want you to freak out. We will be taking this a step-by-step basis, so baby steps. This is just giving you a sense about what we're going to be doing. With that, let's introduce predication without yet introducing quantification. So this, I alluded that our textbook does something a little strange where it still is talking about propositional logic, but it already introduces predication anyway. All right, so here we have, again, 4 sentences. Max is a cat, Max isn't a dog, Max is a cat and a dog. If Max is a cat, then he's not a dog. What we would have done just in propositional logic is for Max is a cat, we might represent that just as the capital letter C. But when we start introducing predication, we will have a predicate, in this case, cat, with a couple with parentheses, and then that as a predicate takes an object as its argument. So something in between these parentheses. In this case, it's Max. So in first order logic, the way that we could represent Max as a cat is this way. It just says the same thing as Max is a cat. Then Max isn't a dog. We still use that handlebar to represent the not or negation. Instead of cat as our predicate, now we have dog. And again, we have Max as our object. That says it is not the case that Max is a dog. Max is a cat and a dog. Before, we would have symbolized this as maybe C and D. But now, since we want to include the predicates, we could represent it this way. Oops. So that says Max is a cat and Max is a dog, which is the same thing as saying Max is a cat and a dog. And in the last sentence, we would use the arrow again with a negation. So we have Max is a cat as we have seen. And it's if then, so as we saw before, that involves the arrow. And then what we have after the then statement is that Max is not a dog. Right? So that says if Max is a cat, then it's not the case that Max is a dog. All right, let's take a look at what it's going to look like once we do introduce quantification. Here we have, again, 4 sentences. Notice in this case, each of our sentences talks about a quantity of something. All dogs, some dogs are not, and no dogs. All right, so how can we symbolize these statements? Well, we're going to have to introduce a couple more symbols to be able to capture this quantity, this notion of quantity. So that says for all x, it's our universal quantifier. And that x is a variable that ranges everything in our domain, whatever it is that we want to be talking about. And we're saying that for everything, if it is a dog, for anything, if we find out that it's a dog, then it's a mammal, which is the same thing as saying all dogs are mammals. And that might be one way that we represent that English statement in first order logic. When we talk about some things, we're going to have to use this quantifier, the existential quantifier. This says there exists an x or some object's x. And we're told that some dogs are German Shepherds. So we're saying that there's something that exists that has two properties. One of those properties is that it's a dog. The other property is that it's a German Shepherd. Right? So there's at least one thing that's both a dog and a German Shepherd, which is just the same thing as saying some dogs are German Shepherds. We might want to say there's something that has a property, but it doesn't have another property, which is what the next sentence does. Some dogs are not German Shepherds. So it's going to look very much the same as the symbolic sentence above, the sentence of FOL above, except we need a negation. Oops, hold on. First we need a conjunction, and then a negation to point out that the thing in question is not a German Shepherd. Right, so this at least one thing has the property of being a dog, but not of a German Shepherd. Same thing as saying some dogs are not German Shepherds. Or we have no dogs are reptiles. There's a couple of ways that we can go about representing this sentence. One way is to say, I'm just going to do one way since this is introductory. One way is to say it's not the case that there exists. We put the negation out in front of the existential quantifier. So to say it's not the case something exists is to say there's none of them. It's not the case that there exists an X such that X is a dog and X is a reptile. So if it's not the case that there exists something that has both of those properties, then there's no dogs that are reptiles. In fact, there's also no reptiles that are dogs. Okay, so what we have done at this point is really just taking a look at what first order logic looks like as a symbolic language as opposed to a natural language. And I wanted to give you a sense about what that symbolism is going to look like as we progress through this course. Now, again, I want to stress we're going to introduce these symbols one at a time. We're going to talk about what they mean one at a time. So we're going to take baby steps with this. It's not something that you should get worried about. What we didn't cover in this video that I was hoping that we would is why you might think that first order logic is important. So since this video is going a little bit longer than I anticipated, I think what we'll do is we'll cut short here, and then I'll make another video for those who are interested in why you might think that first order logic is important. All right, until next time, see you guys later.